This video will be the start of our Unit 7, and on the AP Classroom stuff, it is the AP Curriculum's Unit 6. So what we're going to start talking about is, as you can see from these section titles, we're going to start talking about areas, and that'll be kind of the third big topic of calculus. All right, so throughout the year so far, we spent a little bit of time on limits. That's like the first big concept of calculus. We spent about 2 units on limits. Then for the rest of the year, up until this point, we've been talking about derivatives, taking them and how they help us understand different things about functions. And now we finally get into the third and last big topic of calculus, and that is areas. But we won't use the word area. We're going to use the word integral, and I actually spelt it wrong on the slide. All right. An integral is the area under the curve of the function f of x. So right away, we're going to introduce this notation for what we mean when we want to find area. So when we're doing derivatives, we have this little like prime notation. We also had some dy dx notation. There's a bunch of ways to say we're trying to find the derivative of this function. We're trying to find the area under a function. We use this kind of elongated S looking thing. All right, so this is called an integrand, but that says we're doing an integral, we're doing an area. On the bottom, we have the kind of start of where our area is going to start in terms of the x value. And at the top, we have the end. And then, of course, f of x is our function we care about. All right, it's going to give us some graph that we're finding an area under. And this dx part, just the dx means what variable we care about. So we're doing it in the x direction, this kind of direction like that. All right, for pretty much all of this class, it'll be dx. There'll only be one other time we might change it to a dy, but it's just changing what the x means. So if I think about just a function, it's going to start at the value a, end at the value b. I'll have some function f of x. Let's just say whatever the heck f of x looks like. Maybe it looks like that. And then this whole statement means find this shaded area between our function and the x-axis. All right, so all of this represents that area there. All right, so we're going to do just a few examples of finding an area and just kind of using this integrand notation. All right, so this one I'm going to find the area from 0 to 12. So 0 is the x value here, up to 12. Of this function f of x. And this function f of x has a bunch of different parts to it, but the main thing is, you see, if we look at the area we're trying to find, it's just a bunch of triangles. So this notation means find the area of these blue regions. It's just 3 triangles. So the first triangle, 1/2 base times height. The base here is 1, 2. And the height going up is also 2. And then we're going to add the next triangle, 1/2 base times height. That base, 1, 2, 3, 4, is 4. And the height is up there to also, sorry, didn't realize the scale over here was wrong. This one, the height was only 1, even though it's 2 dashes, it's just a single 1. And the height here is 2. And our last triangle, the base, 1, 2, 3, 4, 5, 6. And the height is there at 3. All right, so we're just going to multiply all these together. All right, this is going to be 1. 8 divided by 2 is 4. 18 divided by 2 is 9. Put together, 5 plus 9 is 14. All right, so our final area is 14. So that is the answer for this integral, the integral from 0 to 12 of this function. We're just trying to basically do geometry and add together these shapes. All right, this one looked really similar. We're still doing the integral from 0, the x value there, to 12 of this function. The only thing that's different with this function is here, this part of our function goes down below the x-axis. And although it doesn't really make sense for area in general, when we're doing these integrals, anything under the x-axis is going to count as a negative area. So it's actually possible to do these area calculations and get a negative number or some stuff canceling out. And we'll see more of this when we look at applications of this area stuff. But just know under the x-axis is going to be negative. All right, so when we go to find this area, we do the first triangle. That's going to be 1/2. The base is 2. The height is 1. Then I'm going to subtract. It's going to be a negative area. The next triangle, 1/2. The base is 4. And the height is 2. I don't want to say the height is negative 2, because if I'm thinking about just the area of a triangle and then I make it negative. So I already took care of the negative with that minus sign. And I add the last triangle, 1/2. The base is 6. And the height is 3. All right, so pretty much the same calculation we had on the last side. It's going to be 1, this is going to be minus 4, plus 9. And now our answer is going to be, let's see, negative 3 plus 9 is 6. All right, so this is my final area. And again, it's different than the first one, even though the first one, the only difference with the first one was this triangle was flipped and it was there. So all the little areas, all the triangles are the same, but by flipping this middle triangle down to the bottom, we make it negative and it cancels out with some of the other area, and we get a much smaller answer over here of 6. All right, so 6 is the area and the answer for this integral. All right, so here's one for you to try on your own. So you can pause the video now and try this on your own just to kind of make sure you're understanding the basic concept. All right, just one hint, these functions don't really matter. Just look at the shapes and try to find the area of this integral.